sine pi into 1 by 4. This one equal to pi upon sine pi by 4. The value of pi by 4 is 1 upon root 2. So pi upon 1 upon root 2. This one equal to root 2 pi. Root 2 pi is option C. So option C is correct. These three vectors are linearly dependent, then the value of alpha is. Set of vectors or given vectors will be linearly dependent or independent on the basis of determinant. If determinant is 0, then linearly dependent. If determinant is not equal to 0, then linearly independent. In terms of rank, set of vectors said to be linearly independent if they are full rank matrix forming, and they are linearly dependent if they form matrix and having rank less than number of variables. The value of gamma 1 upon 4 with product gamma 3 by 4 is. To find this value, if you know the properties of gamma function, gamma x with gamma 1 minus x, this is equal to pi upon sine pi x. This is the formula, and this is not f, this is gamma. So gamma 1 by 4 with gamma 3 by 4 can be written as gamma 1 by 4 gamma 1 minus 1 by 4. This value is 3 by 4. So use above formula. This one equal to pi upon sine pi 1 by 4. Sine pi into 1 by 4. This one equal to pi upon sine pi by 4. The value of pi by 4 is 1 upon root 2. So pi upon 1 upon root 2. This one equal to root 2 pi. Root 2 pi is option C. So option C is correct. Using change of order of integration, this integral is equal to which one option? As this integral is given to us, integral is y equal to x to root 2 minus x square f of xy dy dx, and limit of x is from 0 to 1. We have to change this limit. As x is involved here, so this is the limit of y equal to x, and y equal to square root of 2 minus x square. This represent upper half circle. So upper half circle is this one portion. You can consider. Now this is origin 0 0, and the radius of circle is root 2. This is the equation y equal to x of line. Now first we have to find common region between two limits and curve. As x equal to 0 and x equal to 1, and y is y equal to x and y equal to square root of 2 minus x square. So find first region between two curves. So line and part of circle, if you consider this region, then limit of x-axis is from 0 to 1. So this portion is not coming in this portion. So this is not required portion. Means all this one is not required portion. So required portion is this one. I make another figure to clear the concept. This is required region. Now we have to take integration over this region. So cut the area at this stage. So we have to take integration first, with respect to x, so cut a strip along x-axis, because of when we take a strip along x-axis, then length of the strip change as we change or vary from y-axis to x-axis, along x-axis. So limit of this one is 0 to at this line, because strip is touching at this line. So y equal to x, or you can say x equal to y, and variable limit, sorry, constant limit of this one is from this height, so 0 to 1, plus you can write f of xy dx dy, plus now second reason is this one. So limit of x1, limit of x vary from 1 to, sorry, if you cut the strip as this one parallel to x-axis, then 0 to and touching part of the circle. So in terms of y, right, this is square, and limit is from 1 to root 2. Write f of xy dx dy. Now which one option is giving this answer? We see that. So option D is correct here, 0 to 1, and x is running from, this is 0 to y. This is 0 to y here, and this is 1 to root 2 and 0 to 2 minus y square. This is perfect. Option D is correct answer. Let A be an element of a group G such that a raised to the power 10 is identity and a raised to the power 25 is also identity, and a is non-identity element. Then the order of element A is as given. A raised to the power 10 is identity. It means that order of A is less than equal to 10. Also, order of A divide 10. Second thing is A raised to the power 25 is also identity. This implies that order of A is less than equal to 10, and order of A will divide 25. Sorry, this is also 25. So combine these two. It means that order of A is less than equal to 10, and order of A divide common factor of 25 and 10. Means order of A will be the common factor of 25 and 10. It means that order of A is 5. How? You can write 25 as 5 into 5 and 10 also 2 into 5. This means that this only is a factor which can divide both 10 and 25. So order of A is 5, so option C is correct. If A and B are two matrices of order 5 by 6 and 6 by 5 respectively, then which of the following is true? Determinant of 4 times AB is 4 raised to the power 5, determinant of A and determinant of B. This is determinant of 4 times AB, means somehow related to determinant of AB and a constant 4. In this options B, determinant of BA. In this option CA, again BA, determinant of BA. And in option D, determinant of AB. Means first we need to check product of A and B is defined or not. A is 5 by 6 and B is 6 by 5. So product AB is well defined. Now check product BA is well defined or not. Again, matrices product BA is also defined, and this one will be 6 by 6 of size, and AB is of the size 5 by 5. Now come to the answer. Determinant of 4 times AB. Keep remember, determinant of C times A is equal to C raised to the power n into determinant of A. This n is the size of the size of the matrices, size of the matrices or square matrices. Here BA AB is square matrices of the size 5 by 5. So answer of this one will be 4 raised to the power 5 determinant of AB. It means, using this fact, 4 times AB equal to 4 raised to the power 5 determinant of AB. Option D is correct. Now check if V or C is true or not. Now 4 times BA, determinant of this one, because of size of BA is 6 by 6, so 4 raised to the power 6 determinant of AB. But in option C given is 4 times BA is equal to 4 times BA. So option C is wrong here, and option B is wrong because of individual product of individual determinant. If 4 raised to the power 6 determinant of BA, if it is given, then option B become true. So right option is only D. Let G be a non-abelian group of order 125. Then the total number of element in center of G is how many elements? Number of elements in ZG, or you can say cardinality of ZG. Order of G is 125 and G is non-abelian. Keep remember one point. If order of G is P raised to the power Q, where P is prime and G is non-abelian, then order of center of G equal to P. Means here 125 is given, can be written as 5 raised to the power 3. So order of ZG will be 5. So option A is true. This result is true for all primes. F is a function of x, y, z equal to 0 defines z as a differentiable function of the independent variables x and y, and fx, fy, fz are continuous, then we have to choose correct options. This question is related to about multivariable calculus, and its specific topic is partial derivative. As given, f is a function of x, y, z equal to 0. So I can write f is a function of x, y, z, and also it is given z is the function of x, y. So we need to find partial derivative. So partial derivative of f with respect to x plus partial derivative of f with respect to z, and z is the function of x. So I took partial derivative of f in left hand side, so in right hand side also, so it will be 0. So what I obtained from this one, so I can write partial z with respect to x can be written as minus partial f divided by partial f upon partial z. Partial f with respect to x can be written as zx equal to minus fx divided by fz. Now from this is the equation 1. So find which one option And also this is defined when fz is not equal to 0. So which one option is giving zx equal to minus fx upon fz minus fx upon fz. So option A discard here. Now check option C, minus fx upon fz, option C containing, but need to check partial z with respect to y also. And option D discard because of positive sign, partial z with respect to x equal to fx upon fz. So this option discard. Now we have only two choices. Now find partial derivative of f with respect to y. So partial derivative of f with respect to y plus, because of f is a function of y, also f is a function of z, and z is the function of y also. So right hand side will be 0 because of I took partial derivative of f in left hand side. So right hand side also 0. So what I obtained from this one, partial z with respect to y equal to minus of partial f with respect to y divided by partial f divided by partial z. In compact form or more good looking form, I can write partial z with respect to y, zy equal to minus fy upon fz. So zy is also negative. So you can see in option B, partial z with respect to y equal to minus fy upon fz. Also fz not equal to 0 in this option. So option B will be right, and option C discard because of, you can see in this part negative sign is not there. Let V is equal to M2 by 2 matrices over R, we have vector space, and matrix M is given by this structure. Let T is a linear transformation from defined vector space V to same vector space V such that T of A means image of A under T is A minus MA. A basis for kernel T defined as, means we have to tell about basis. Four options are given to us and we have to choose perfect or good option for this problem. As matrix M is given 1 0 2 3 and V is a vector space M2 by 2 over R, and dimension of this vector space V is 4. We have to find basis for kernel T. Let us consider a matrix 2 by 2. Elements are A, B, C, D. It is general form of 2 by 2 matrices over R. If this element A is belong to kernel T, then by the definition of kernel T, T of A is equal to 0 by definition of kernel T. It means that AM minus MA, as this is given, equal to 0. Now consider A multiply with B. M, A is A, B, C, D, and matrix M is 1 0 2 3 minus 1 2 0 3, and matrix A, B, C, D is equal to 0 matrix of the correct size as 2 by 2. So 2 by 2 size of 0 matrix. This give us minus 2, 2a plus 2b minus 2 times d, or 2c is equal to 0. It means that 2 is equal to 0 and 2a plus 2b minus 2d is equal to 0 by comparison of two matrices when they have same type and same size. This implies that c equal to 0 and 2a plus 2b minus 2d equal to 0. This means that a plus b minus d is 0. C is 0 and this condition. It means that matrix A having this structure, A is free, B is also free, C value of C is 0 and D is, by this A plus B equal to D. So this is the structure of element A, which is belonging to kernel. So we have to find basis. So basis is linearly independent and spanning set. So I'm going to write few elements of linearly independent set as 1001. Take 1 at the position of A and other element as 0. So this one is the element of basis 0011. This will be another element of linearly. Let A equal to this matrix, then A is the root of fx where fx is one of them. A matrix A is given row wise 1, 2, 3, minus 4. This is matrix A. Determinant of this matrix A is minus 4 minus 6 equal to minus 10, and trace of this matrix A is sum of diagonal element, this one equal to minus 3. Using these two, we can generate characteristic polynomial in terms of x. It can be written as x square minus trace, then minus minus turns to positive. So 3x plus determinant is minus 10. It means x square plus 3x minus 10. This is option D. And using Cayley-Hamilton theorem, matrix A satisfy this Kerr equation. This is by mathematician Cayley. So this theorem is known as Cayley-Hamilton theorem. Means a square plus 3a minus 10 times identity will give you 0 matrix. Means matrix A satisfy this one. So option D is correct. Consider the system. This system has a unique solution if condition on K is given to us. For options associated this problem is given. So system has unique solution in terms of rank. We can say rank of coefficient matrix equal to rank of augmented matrix equal to number of variable. In terms of determinant, we can say coefficient matrix determinant not equal to 0. We have two approaches. We can draw conclusion using these two. So I'm going to solve this problem by rank. So K1 1, 1K1, 1 1K and 1 1 1. This is last column in right hand side as B1 B2 B3. You can understand. By the elementary row operation, we can make entry below the leading or pivot entry. Below the pivot entry, we can make 0 applying elementary row operation. This is somehow known as elimination method. So by elementary row operation, first row is same 1 1 1. This becomes 0 and this one will be k square minus 1, k minus 1, and this is also k minus 1. This is 0, k minus 1, k square minus 1, and this is again k minus 1. This is last equivalent matrix. So for unique solution, rank of this one matrix should be 3 because of number of variable is 3. It means, for example, if we are not saying because of k minus 1 is involved here, k minus 1 is involved here, and k minus 1 is involved here. In all these last non-zero last row entries, k minus 1 involved. So we cannot draw conclusion by this one and this one. If anyhow, whatever this number, this is suppose either 0 or not 0. But if this is not equal to 0, not 0, then this matrix become full rank matrix. And anyhow, we can make this entry 0 because of elementary row operation or elimination process. So most important thing is that these two entry will help us to draw conclusion. This is not important. But by the chance k minus 1 is this and these two entry are same. So if k minus 1 is 0, if k minus 1 is 0, it means that k square minus 1 is also 0 because of k minus 1 is the factor in this one. Means all three entries in last row become 0 and this matrix reduce in lower rank matrix or rank 2 or 1 matrix, rank 1 matrix. So we cannot choose the value of k as 1. It means k not equal to 1. In option A, B, k equal to 1. So option A and B discard here. Now option C and D might be true or both become true. But condition on k is also given is k equal to minus 2 or 2. So using this fact, rank we cannot find another condition. So approach this problem by determinant. So we are going to find determinant of this coefficient matrix. Along expand this matrix by first row. So k square minus 1 minus 1, k minus 1, and this is plus 1, 1 minus k. This is 1 minus k. This is equal to k cube minus k plus 1 minus k. This means that k cube minus 3k plus 2 and determinant of this one not equal to 0 because of determinant 0, lower rank matrix. So which root is satisfying k square minus 3k plus 2 means k equal to 1 and k equal to 2 is satisfying this k equal to minus 2 because of this one become minus 8 plus 6 and plus 2. So k equal to minus 2 satisfying this one and k equal to 1 is also satisfying this one. Means k not equal to 1 and k not equal to minus 2 make this condition determinant should not equal to 0. Now we have two condition on k, means k should not equal to minus 2, means option C is correct. Let T is a linear transformation defined from R cube to R cube such that image of 001 under T is 235 and image of other elements is as given. Then find the image of 101 under T. This type of question asked in many times, but it is simplest one as T001 is given to us 235, T111 is 0 1 minus 1, and last one element, image of one element is also given. This is 1 0 0, and ask the image of 1 0 1. What is the image of this element under T? First, check that these domain elements are forming linearly independent set or not. If they are forming linearly independent set, then they will form basis, because of number of linearly independent becomes the dimension of the vector space, so they will form basis. This is by theorem. And write each domain element is the linear combination of basis element and image of any element. Write the basis for codomain. But there is no need to check whenever this type of question asked. This may be solved by a trick. Write this element with the help of given element as, so write 1 0 1 1 0 1. This one can be written as 0 0 1 plus 1 1 1 minus 0 1 1. Now this is perfect. Now we have to find image of this, so apply T or linear function or linear map. Now image of these elements is given as 0 0 1. This is image 2 3 5 plus 1 1 1 0 1 minus 1, and image of this element is 1 0 0. These are order pair, so 2 minus 1 give you 1, 3 plus 1 4, and 5 minus 1 4. 1 4 4 is the image of this asked element, so option C is correct. F of x y z. This is a scalar function. Now gradient of f will give you normal to the surface, normal to the given surface. So find gradient f. This one will be partial f with respect to x I hat plus partial f with respect to y j hat plus partial f with respect to z k hat, and this one equal to 2x I hat plus 2y j hat plus 2z k hat. Now we have to find normal. This is normal vector. Now we have to find normal vector at 1 1 1. So put xyz coordinate in this normal. So this one equal to 2 I hat plus 2 j hat plus 2 k hat. This is normal, but we have to find normal unit vector. So how to make this vector as a unit vector? 2 I cap plus 2 j cap plus 2 k cap divided by square root of 2 square plus 2 square plus 2 square. This is nothing but 2 root 4 4 8 and 4 12. 4 3 is 12. So 2 root 3, and this one equal to 2 I hat plus j hat, 2 times j hat plus 2 times k hat. 2 cancel out by common factor of the vector. So I hat plus j hat plus k hat divided by root 3. This one equal to I hat upon root 3 plus j hat upon root 3 plus k hat upon root 3. And which one option is giving this